Okay, we can start now. Good morning, everyone. Today's workshop number 141, and our topic is HDB, exemplary builder for BIM and BDC practices, and kind representing this topic. And you may proceed, Kai. Thank you. Mhm.
Hey, good morning, everyone. Today, I would like to share the slide we presented at HDB for the Tango project, and I share the CES digital transformation journey, a story of moving from traditional construction method to become the aspiring contractor in VDC and IDD. At the center of this journey, I will share with you our work on Tango Brickler Princess, a key project and the Singapore Visionaries Plan for smart and sustainable towns. My topic will cover project images or digital transformation journey, IDD use cases, project outcomes, KPI. Okay. Our project breakdown with consists of 6041 training units. There are 12 residential block, 2 multi-story carpet, 3 electrical substation, a various communal facility. The project span is 42 months from December 2023 to July 2027. Is also adopted DFME framework and implemented VDC and IDD digital use cases. So I will share a bit about our CES. TBC has a long-standing reputation in Singapore environments. Our first HDB project in 1982 with uh, 168 units. The iconic Pinnacle at Destin in 2009 with 1844 training units, a total of 60,000 overflow space for the last 10 years. The presence we have got Lieutenant Bank and Glades, Briglam with Coban Westspring and Coastal Group at the Passaris, and the reasons were Asia, Meltonia, and Sankan. Business focus on building construction, civil infrastructure, 3D printing, environmental and property developments and investment, and also hospitality and education. The need to change. We, with decade of experience delivering public and private developments like many contractors, we started with a traditional method of project coordinations, things to the drawing, site-based issue resolutions, and coordination through emails, meetings, and paper-based process. The need to change, adapting technology to maintain our advantage. 2D methods were in the past, but as the project's complexity grows, so did the risk, clash on site, delay due to miscommunications, costly rework, and silo workflow. We knew that to stay ahead, we have to change the way we build, adopting technology to gain competitive advantage or at least keep it. The transition from 2D using color pencil to work on drawings to study level to 3D design offers numerous advantages, including improved visualizations, accuracy, and efficiency, ultimately leading to faster design cycle, better product quality, and reduced costs. Our digital transformations. Our digital journey didn't happen overnight. It's evolved over a decade. In 2016, we started with early stage BIM modeling, mainly for design purposes. By 2017, we were using clash detection to improve design coordinations. In 2018, we introduced VDC using 4D simulations to visualize construction sequence for tendering and planning. In 2019, we adopted virtual reality, allowing stakeholders to interact with design virtually. A big milestone in 2020 was the shift from demo mockups to virtual mockup Unix VMU. This reduced waste and speed up approval. By 2021, we fully embrace IDD workflows, integrating digital process across design, fabrication, and constructions. Looking forward in 2025, we are piloting a virtual TOP in one of our HDB projects, a major step towards digital handover. We were also exploring AI, such as Document AI, which help us extract structured data from unstructured documents like PDF or scan report. We began these transformations because of the growing complexity in the project, with increasing design demands, tighter schedule, and more stakeholder. traditional methods were no longer sufficient. There were a clear there was a clear need for faster coordinations, a higher accuracy. On top of that, there was also a strong national push from PCA to implement IDDs, which give us the frameworks and motivations to act. Most importantly, our progress wouldn't have been possible without the close collaboration of everyone involved, the architect, engineers, subcontractors, Trigger, and yes, our top management teams, together with the guidance and support of our director, Mr. Stanley. So uh, our turning point came uh, when we embraced VDC and IDD. With VDCs, we began to simulate construction digitally before breaking grounds, using 3D, 4D, and 5D beams model to plan and coordinate our work at breakground wave. This allowed us to detect clash early, plan logistics more efficiently, and align our team and consultant from the start. But it was through IDDs and the use of the platform like ACCs that we saw the real power of digital collaborations with the common data environments. Everyone from architects, engineer, and MEP contractor to our site supervisor and subcons are working from the same platforms, single source of truth. A number of firms has been already recognized for their success in embracing digital constructions at 2021 PCE IDD Award. If your firm isn't one of them, you could be left behind. Streamlining projects through the technology can give your organization a competitive advantage. If IDD isn't on your radar, you are falling behind. So I share how embracing VDC and IDD can unlock new possibility in our project. IDD use cases we have implemented at Tango Brickland. These are aligned with the PCA IDD framework and demonstrate how digital tools are being applied across the entire project lifecycle, from the beginnings, from the design orderings to coordination, construction, and documentations. BIM order orderings. We began with BIM order orderings. We used Revit 2023 form modelings across all discipline and BIM Collab Pro, which integrated with ACC for issues tracking and collaborations. For model coordinations, we perform clash detection using Naviswork. Any issues found are published to ACC, where there are pins already on the model for the precise issues locations. Precise issue locations and resolutions trackings. This helps us manage inter and interdisciplinary clashes early, improving model quality from the start. We also analyze the issues using dashboards data generated from ACC. These dashboards help us track issues volume by discipline, resolution timelines, and recurring clash categories, which enable faster decision makings. Digital RFI. We have established a digital RFI workflow using ACC. RFI are created, assign and track within the platforms with version control and audit log for traceability. This eliminates confusion caused by email and ensure timely response. We also maintain a CES RFI workflow, which standardizes how RFI are routed from the site teams to the consultant. Our RFI Insight dashboard in table view break down the number of RFIs submitted by categories, turnaround times, and disciplines. This helps us monitor consultants' response time and identify recurring technical queries that may need design refinements. Digital submissions and approval. We use ACC submitter for digital submissions and approval process. Key deliverable like method statements, shop drawings, and material submissions are uploaded for consultant review. Reviewer can comment and approve directly within the system. This reduces delays and ensures the latest version is always accessible. Our internal RFA workflow is structured to streamline submissions from site engineer to consultants via ACC. We also maintain an RFA inside dashboard, which display RFA counts by disciplines, average response time, and submissions trend since project inceptions. Integrated concurrence engineering ICE meetings. We conducted ICE meeting for live model review with all stakeholders by working of the live model during meetings. We can solve the issues in real time rather than through multiple follow-ups. We use share screen, beam visualization, and the meetings module in ACC log to log and track action items. This process improves coordination and significantly speed up the decision makings across disciplines. Model quality assurance. Model quality is essential. We use Planoly to monitor the model updates. Each resolve issues RFI and RFA is verified using the checklist items to ensure it's reflected in the updated model. Deliverables from the paint teams are sent to the project team for review via ACC review, where they are checked and verified before the formal release. This workflow ensures that only quality assured model and drawings are used on site. 3D visualization. We use 3D visualization for design review, spatial planning, and construction coordinations. This allows us to better assess unit layout, MEP routines, and command space. Sorry. Conflict or space constraints. Conflict or space constraints are easier to detect visually than in 2D. We also use vector walkthrough generated from the BIM model to communicate design with non-technical stakeholder to support client review. These two enhance understanding and speed up the approval process. We conduct visualization and design check. We conduct visual walkthrough to validate both unit layout and command area. This helps us identify spatial inefficiency and mismatched component early, issues that are difficult to catch in the 2D drawings. We also implement virtual mockups Unix VMU, replacing the traditional timber mockup. Using VRIA, we gather feedback from the clients and end user before the construction begins. This improves coordination and helps stakeholders visualize the final products, leading to smoother approval and fewer changes during the constructions. Digital construction scheduling and sequencing. We use 4D beams to link construction activities to the model, simulating the construction sequence over time. This gives the teams a clear view of how the project will be built step by step and allow us to spot conflicts or inefficiency early. It also improves coordinations across trade by clarifying when and where each trade is working, reducing overlaps and downtimes. We use these simulations to support master program planning, construction staging review, and submissions. Digital progress monitoring. To track progress, we link site update to BIM model elements. This allows us to visualize plan versus accurate progress directly in the model. This visual effects help us spot delay and resequence work if needed. It enhances reporting and helps the teams respond quickly to on-site issues. Aspect documentations. This future use cases under developments. We are preparing to submit aspect model that reflect accurate site conditions updated progressively throughout the constructions. This model will meet HDB digital handover requirement and support future facility management. This ensures continuity and long-term asset management once the project is handed over. Data analysis using TableView. We extracted data from ACC, including RFI, RFAs, and the issues log, and analysis using TableView dashboard. This helps us monitor the project's health and identify trends such as common issues type, consultant performance, and process delay. With data insights, we can drive continuous improvement and make proactive decisions. BIM management with Planoly. Lastly, we use Planoly to manage our BIM execution plans. It helps track modeling progress, milestone alignment with the master programs, and BIM teams manpower allocations. Planoly offers a Kanban dashboard that gives us a visual overview of task assignment, progress status, and pending actions. This centralized management ensures accountability and faster resolution of issues. Okay. Project outcomes. Overall, we I would like to share that most of our digital use cases are over 75 implemented, and we will continue refining them as construction advances. To wrap up, implementing these IDD use cases have greatly enhanced collaborations, transparency, and efficiency in the breakdown with project. More than just adopting digital tools, we have seen a shift in the mindsets with all stakeholders aligned in the common digital environments and focus on delivering quality housing project. Okay, thank you for your attention.
Thank you, Kai. Do you have any question for Kai? Okay.
Okay. Can I ask you one question?
Yes.
If we go to the page number 2, I want to ask something about the digital turnover. You could do the your page number 2 or 3.
This one is it?
Not this one.
Oh, digital
Page
handover.
number 2.
Oh, I saw.
Yes.
Okay. It's the one.
I think this one, yeah. Virtual TOP, right? This
Yes.
is how, yeah, how inside, how to support on this one.
We use our 360 camera to scan the accurate on-site, and there will in the browser there will be a comparison view of the on-site our model and the on-site actual model, so that they can check the comparison, and when they do the inspections, they can use these platforms to review the model, the review on-site securations and the model.
Oh, so our side is have to provide the only model. That means last time we already done on the VMU, right? Is it same?
Not only VMU, the block, like a common area,
Block.
staircase,
Oh.
riser wall. Just
No,
like in
that so
our
meaning
other project, we during the PID inspection or QB inspections, the officer they come down to site to check manually. Now we use the 360 camera to scan our buildings, and we upload it to our platforms. Then there will be we also need to upload our model to there, and there will be a comparison view model versus actual on site. Yeah.
okay, no that so meaning that our side have to prepare the all aspect model. It's
Yes,
like aspect
correct.
model
Yes,
to comparison the actual one.
yes,
So we have to prepare the actual model for all area.
yes,
Like the
yeah,
minutes like that. Okay, thank
yes.
you.
Thank you.
Do you have any question? Okay, if you don't have any question, we can proceed now on with the please. Thank you, Kai. Thank you, everyone.
Thank you, guys. Thank you.
Thank you, Kai. Thanks, Sarah.